Hello everyone. Today we are going to discuss types of linked list. How many types of linked list do we have? As you can see on the screen, we have these four types of linked list: singly linked list, doubly linked list, circular linked list, and doubly circular linked list. So these are the basically most commonly used linked list in our programming languages. And apart from this, we can also create our own linked list beyond these four linked lists, right? So let's understand one by one how it basically works behind the scene and what is the logical representation of each and every linked list. So let's move on to the first singly linked list. Yeah. So as you can see on the screen, that singly linked list is basically having having the nodes for representing the nodes. As you can see, for single linked list, we can declare a structure, and that structure is basically containing two members, that is one data member and another is next pointer. So this integer variable is basically going to hold the actual data, and the next pointer which we have declared of type struct node, it's going to hold the address of the next node. So let's suppose these each and every are the nodes defined in the linked list, as you can see this, right? So if we take a first node, and this node is of struct type node, as we have declared structure for this node, right? So each and every node is containing two parts, data part and the address part. Data part, address part, data part, address part. This node is also data part, address part, data part, address part, and similarly the last node, data part and the address part. So if we are talking for the first node, as I told you that it's going to contain two parts. One is for data part and one is for next part, or we can say a link, or we can take whatever we feel like, next or link. So this part is going to hold the address of the next node in the linked list, right? Similarly, in this node, in the next part of this node, it's going to hold the address of the next node. You can see each and every node in the memory is being assigned some addresses. Like for example, for this address we have address 100, for this node 200, for this node 300, and for this node 400, and for this node 600. Similarly, it goes on till the nth element in the linked list, right? So yeah, so we were talking about this next pointer. So next pointer is going to hold the address of the next node, right? Or we can see this is a pointer which is going to point to the next node. This is a pointer which is going to point to the next node, right? And similarly it keeps on repeating till last node, right? So when we are working with a single linked list, and let me tell you one more thing, that it is the most commonly used linked list in the data structures and algorithm, right? So let's suppose we want to delete this node, right? And we want to perform any kind of operation like insertion, deletion, right? So for doing any kind of operation in a given linked list, what we have to do, we always have been assigned one head pointer, right? And that head pointer is going to contain the address of the first node, that is this, right? We can take as a start pointer or head pointer, whatever you feel like, right? So over here we have take one head pointer, and this pointer is also of type struct node, which is going to hold the address of next node, right? So it's a pointer type, it's a pointer type variable which is going to hold the address of the next node, right? So as you can see in this pointer variable, the address is being stored 100. So it's going to point to first node, and similarly this node is going to point next node, this node is going to point next node, and similarly we can sequentially access each and every node till the last node of the linked list, right? And one more thing, while traversing through the linked list, when we reach to the node which node is having null in its next part, that means we have reached to the end of the linked list. So for example, if any node containing null part in its next address, that means it is the last element in a given linked list, right? So that's a very you can say a logical diagram which is represented behind the scene, how basically linked list works in the memory of any compiler, right? So that's a single linked list. And let's suppose we want to delete any element or we want to delete any node from the linked list, or we want to insert at any position in the linked list. So we need one temp pointer variable that is of the same type, struct node, which is going to hold the address of the node type, right? So similarly, as we have taken this head pointer, we can take one more temp pointer, and with the help of that temp pointer we can traverse through the linked list of each and every node, right? So that's a single linked list. Now let's move on to the doubly linked list, right? So yeah, so this is your double linked list. So by looking into this diagram, you can see that in a single linked list we were having only one pointer, but in the double linked list we are going to maintain two pointers, right? As you can see the structure of the node in a doubly linked list, we are having three members here. One is for maintaining the data part, and one is for maintaining the next pointer, which is going to hold the address of the next node in a linked list, and one is for previous pointer, which is going to hold the address of the previous node, right? So that's a very basic structure for doubly linked list. Now let's move on to this pictorial representation of doubly linked list. So in a linked list you can see that specifically in a doubly linked list, each and every node is having three parts: data part and the next pointer and the previous pointer, data part, next pointer and the previous pointer. Similarly, data part, next pointer and the previous pointer, and similarly the last node is also having data part, next pointer and the previous pointer. So in this as we can see that each and every node is having two pointers. So in the next part it's going to hold the address of the next node, and in the previous part it's going to hold the address of the previous node. We can take any node, for example this node is going to in its next part it's going to hold the address of the next node. It's going to point to the next node, right? And in the previous part of this node it's going to hold the address of the previous node. See, it's holding 200, so it is pointing to this node, right? So this is the basically main difference between single linked list and the doubly linked list, that in the doubly linked list we are maintaining two pointers, and in the single linked list we are maintaining only one pointer. So and similarly we are having one head pointer which is going to point to the first node in the linked list. So in the head pointer we are having the address 100, so it's pointing to the first node, right? And with the help of this we can traverse to each and every element in the linked list, right? So that's a very basic concept about doubly linked list. And in the last node you can see that in the next part of the last node we are having null. That means that is the last element in this particular linked list, right? So that's a example of doubly linked list. Now let's move on to the circular linked list. Circular linked list is nothing, we can say it's a variation of a single linked list, or we can say it's a advanced version of a single linked list, right? So in a single linked list, as we discussed that we are having two part, data part and the next pointer, which is going to hold the address of the next node, right? So the concept remains same in circular linked list also. We can see that this first node is containing the address of this next node, and this node in the next part of this node is going to contain the address of the next node. This node is pointing to the next node, and this node is pointing to the next node, and similarly it is pointing to the last node, right? But in the last node, the difference is that when we are working with circular linked list, in the last node we are going to assign the address of the first node, right? You can see in the last node we are going to assign the address of the first node, which is pointing to the first node, right? So that is the example of circular linked list. So your last node is connected to the first node, right? So this is a circular linked list, right? And the structure for defining the node in circular linked list will remain same, right? We are having one data part for storing the actual data, and the next pointer which is going to hold the address of the next node of type struct type node, right? This and this, right? Yeah. So that was all about the circular linked list. Now let's move to the last topic, that is doubly circular linked list. What is happening in this? When we are working with a circular doubly linked list, that means we are talking we can see that it's an advanced version of doubly linked list, right? Same, we are having the same structure as we were maintaining in the doubly linked list, right? You can see in the doubly linked list, yeah, doubly linked list we were having the same structure. We are having one data part and the two pointer variable next and previous. The same we are having in the circular doubly linked list. You can see this, right? Next pointer for holding the address of the next address, and the previous pointer for holding the address of the previous node. So the concept remains same in circular or doubly linked list as in the case of doubly linked list. The only difference is that your last node is connected to the first node, you can see in the diagram, and your first node is connected to the last node, right? So that's an example of circular doubly linked list. We can see that in the last node, in the next part of the last node, it is going to point to the first node of the linked list, right? You can see it's containing the address 100, and it is going to point to the first node. Plus, what we have to do, plus in the first node, in the previous part of the first node, we are going to assign the address of the last node. You can see this. So address of the last node is 400. So we are assigning in the previous part of the first node 400 over here to make it circular doubly linked list, right? And the rest will remain the same as in the case of doubly linked list. Each and every node is having three part: data part, next pointer, previous pointer, data part, next pointer, previous pointer, and each and every pointer, next pointer is going to hold the address of the next node, and the previous pointer is going to hold the address of the previous node. So that is all. So that was all a very brief introduction about the types of linked list, what we have in our linked list. So in the upcoming videos we are going to discuss all kind of operations like insertion, operation, deletions, and we are going to solve problems related to the linked list which are most commonly asked in the top IT companies like Microsoft, Google, Amazon, right? So in the upcoming videos we are going to solve the problems related to this linked list. For example, like Geek for Geeks and Lead Code. So we are going to I'm going to provide the solution for each and every problem in my upcoming videos. So that's it from my side. Thank you so much. Bye bye. Take care.